A circle is the locus of points in a plane equal distance from a fixed point. If I draw a circle for you, and I put the center point in the middle, anywhere I measure from the center to an end of the circle would be the exact same length, and they would be called your radius. So the circle is a locus of points in a plane equal distance from the fixed point, which is the center. Equations of a circle whose center is the origin is x squared plus y squared equals r squared, r representing your radius. And when there are no numbers attached to x and y with either addition or subtraction signs, your center then is the origin, which means your center is 0, 0. When the equation of a circle has a center that is not 0, 0, it is considered to be x minus h squared plus y minus k, the whole thing squared, equals r squared. Again, r is your radius. Since the equation contains subtraction signs, the center is the opposite of what's in the equation. So in this case, your center would be a positive h and a positive k. If I was to write the equation of a circle as x plus h quantity squared plus y plus k quantity squared equals r squared. In this case, my center would be negative h, negative k, because it's the opposite of what's given in the equation. This next step is a little new for you this year. Standard form of an equation of a circle, which is expressed as x squared plus y squared plus cx plus dy plus e equals 0. When an equation appears in standard form, it is often beneficial to convert it to center radius form, which is what we just talked about above, by using the method called completing of the square. And you already know how to do completing of the square since we've done it quite a bit this year. If you're going to convert center radius form then to standard form, the best method would be to multiply the equation and then set it equal to 0. If you're going to sketch a circle, you must determine the center and the radius. Okay, with this all being said, let's talk a little bit more about center radius. Find the center and the radius of each circle. For number 1, x squared plus y squared equals 49. Since there aren't any numbers attached to the x and the y, my center in this case would be 0, 0. My radius is, well, you have to think about it. What number squared would give you 49? You're correct, it's 7. And it's only going to be the positive 7 because you're talking about a measurement. If it's unclear to you, please remember the radius is r squared. So to get r by itself, you would take the square root. So in this case, we took the square root of 49. Let's move on to number 2. To find the center radius of that equation, your center again would be 0, 0. And your radius would be, well, I don't have a number. That 1 squared gives me 75, so I have to take the square root of 75, which if I simplified it would be 25 times 3. So therefore my radius would be 5 radical 3. All right, with that being said, let's go on to number 3. They give you the equation of a circle. In this case, x and y are not by themselves. They are accompanied by numbers. Remember what we said. Your center is the opposite of what's given in the equation. So in this case, my center is going to be a positive 3 and a negative 4. And my radius is going to be the square root of 64, which is 8. Let's do number 4. Here the center is going to be 0, positive 7. The reason it's 0 is because there's no number attached to the x squared. And my radius is, you're correct, 3, because the square root of 9 is 3. Okay, with that being said, if I wanted to take number 3 and actually put it in my calculator and graph it, I would have to get y by itself. So let's practice that a little bit. Let's actually do our graphing calculator steps. So let's practice how to get y by itself. So the equation is x minus 3 squared plus y plus 4 quantity squared equals 64. If I wanted to put in my calculator, I need to get y by itself. So the first thing I'm going to do is I'm going to subtract x minus 3 quantity squared on both sides. So I will end up with y plus 4 quantity squared equals 64 minus x minus 3 quantity squared. I still don't have y by itself. My next step would be to get rid of the squaring. So the opposite of squaring is to square root. So I'm going to square root both sides. On the left, I'll end up with y plus 4. Since I'm square rooting, on the right I'm going to end up with plus or minus the square root of 64 minus x minus 3 quantity squared. And all that is under the radical. I still don't have y by itself, so all I have left now to do is to subtract 4 on both sides. So I will end up with y equals plus or minus the square root of 64 minus x minus 3 quantity squared minus 4 outside the radical. Or I could have written it as y equals negative 4 plus or minus the square root of 64 minus x minus 3 quantity squared. So again, it really isn't that difficult to get y by itself. You just have to take your time and move one thing at a time from one side to the other. Let's move on. Taking a look at number 5. The directions say write an equation of each circle given the center and the radius. Okay, with number 5, the center is 0, 0. And if you remember, when the center is 0, 0, there's no number attached to the x squared, y squared. So we have x squared plus y squared equals. The radius is 4, but in the equation, you take the radius and you square it, so it equals now 16. With number 6, the center is 1, negative 5, and the radius is 3. Remember, when you put in the center to the equation, you're putting in the opposite value. So we'll have parentheses x minus 1 quantity squared plus parentheses y plus 5 quantity squared equals the radius squared would be 9. Now think about it. Isn't it true, looking at that equation, its center would have to be positive 1, negative 5 because it's the opposite of what's in the equation? So we did that correctly. We're going to save number 7 for class tomorrow because graphing, we're going to need to look at the graphing calculator. But let's go down to number 8. They want us to sketch. And what we read on the page prior to this was that in order to sketch, we need to have the center and the radius. All right, so in this case, the center is going to be positive 2, negative 1. And my radius is going to be 3. So to sketch a circle using center radius, you actually plot the point for the center first. So we need to plot positive 2, negative 1. So it's positive 2, negative 1, which should be right there. And from there, you count up 3, right 3, down 3, and left 3. Why 3? Because your radius is 3, to plot your outer points of the circle. So we're going to count up 3, and I'll do it in a different color so you can see it a little clearer. So we've got 1, 2, 3, there's a point. To the right 3, 1, 2, 3, there's a point. Down 3, 1, 2, 3, there's a point. And left 3, 1, 2, 3, there's a point. And then what you do is you connect your outermost points. So as you see, my center of this circle is 2, negative 1, and my radius is 3, because if I drew a line from my center to my radius and counted, it definitely is 3 spaces above, or 3 spaces to the right, or 3 spaces below, and of course 3 spaces left. So then you actually would do the last step, which would be to name your circle. which is x minus 2 quantity squared plus y plus 1 quantity squared equals 9. So that's how you sketch a circle using its center and radius. So tomorrow we're going to come into class, and the first thing we're going to do is we're going to actually graph number 7 together. So what we're going to need to do in order to put it into our graphing calculator is to get y by itself. So if you want to try to fool around with that a little bit tonight, go right ahead and see if you can get y by itself, and see if you do it right when we do it together tomorrow. We'll see you in class tomorrow. Have a good evening.